All right, hi everyone. We're looking at our test 2 review for rational functions. Remember, these functions are fractions, right? And what are some characteristics that lead us to graphing these, with less work. So our first question is simply, what is the vertical asymptote? And if you please remember that the vertical asymptote is not the top, is when the bottom goes to 0. And hopefully you guys can automatically spot it is if x was -6, we would have a vertical asymptote. So in this problem, they want us to write x is equal to -6. That's it. That's why this question is no work. So we need work for questions only number 3 in this case, but no work for questions 2, 4, 5, 6. 1, 2, 4, 5, 6. All right, next question. Take a look here. We might have a 0 at 0. Sure, that's an x-intercept. But looking at the bottom, we want x plus 2 to equal 0. X is -2. And in this case, identify the restrictions. What values can x not be? X cannot be +2. Oh, sorry, -2. Oh, my bad. -2. And the reason why, because if we plug in -2, even if you plug it on top, we end up dividing by 0. And that's, remember, undefined. And please, I hope you guys understand the reason why it's undefined is because this shoots up to infinity. We don't know if it's positive infinity or negative infinity. We just know it's not a number that we can use. And hopefully you guys also remember why it shoots up to infinity. If I say -10 over 0.1, a small number divided by a big number gives you a big number. A even smaller number divided by a big number divided by even smaller number becomes even bigger. It's even bigger now. Okay. Let's look at our next problem here. Okay, what numbers are we not allowed to use? I don't know, but perhaps I can factor it. Now I'm going to go ahead and factor the top 2 while we're at it. Okay, take out the -2. On the bottom, what 2 numbers multiplied to become 72? I don't know. 1 times 72, 2 times 36. Man, how'd you do it so quickly, Mr. Go? I actually divided. 2 goes into 7 3 times, right? That's 6, remainder 1. 2 goes into 12 6 times, right? I can divide by 3. 3 goes into 7 2 times, remainder 12. 2 goes into 12 4 times, so 24. Let's do 4. Yep, we can do 4. 2 goes into 36. Let me do that one more time. That's 4 and 18. Let's see, are there any other options? Let's keep on going. 5, 6. We know we can do 6. 6 is going to be 1 and 2. 7 and 7 doesn't work, right? Does 8 work? 8 does work. 8 and 9. All right, so these are my only options for breaking up 72. Do any of these options here, take a look here, do any of these add up to become 17? See, we add to become 17. And maybe you already thought about 8 and 9, right? That's always the one that we probably would have checked. I would have tried 8 and 9, but I want to show you guys all the possibilities. And none of these other possibilities here add up to become 17. So we know our factors are going to become x plus 8, x plus 9. Okay. Now, what values can we not use because we would be dividing by 0? If we use them, x cannot be -8 and -9. Right? Those are our restrictions. But also remember, these are also our vertical asymptotes. So we have vertical asymptote -8 and -9. Okay, let's look at question number... So I asked you question number 3, why does this require work? Because I needed you guys to show me that you factored the problem. If you didn't factor the problem, I'm going to consider that as no work, and I'm going to ask you for work. I'm not going to give you points for it. Okay? So make sure you do show me work. Now, question number 4, we have what numbers make this go to 0? If I want to just factor it, 6 goes into 6x once and 1, and we have x minus 5. Making this go to 0, only one number, that's 5. Now, we talked about domain before. We had practiced this, and this was in your homework. If every number works except 5, we can go from -infinity, comma, to 5, stop, and then we're going to union from positive infinity. Sorry, oh darn it, I'm sorry, I was thinking about the wrong way. We hop back on the bus at 5 to infinity. Okay, so make sure you practice that, because if that's on the test, you need to remember how to write that. If I want to talk about the graph itself, we have vertical asymptote at 1, 2, 3, 4, 5, dot, 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 dot. We have a horizontal asymptote. Take a look here, horizontal asymptote at 6, up here. And I'm thinking about the graph goes something like that. Wow, how'd you do so quickly? Actually, I kind of cheated. I said, what numbers, isn't any number after 5, 6, 7, 8, isn't that all positive? So the top and bottom will both be positive. We're going to be on top for sure up here. We would never be negative with those numbers. And also, if you want, you can see that my 0, oh wait, I have a 0 at -1 actually. Whoops, how come 0 is -1? Maybe the graph would be like over here. That's an interesting 0. What's my 0? If I plug that in, 0, that's going to be negative. Oh yeah, negative 1.5. Like over here. So I guess the graph looks something like that. Okay, so I'm a little farther than I thought. That's not bad still. Okay, so we would have to write this from my domain. This is my domain here. So we go from negative infinity, right? We take a break at 5, we hop back on at 5 and keep on going. Oh my gosh, it's raining outside again. Except the sun is out. It's so scary. Okay, so the next problem here, let's go take a look. Identify any restrictions we have, and then identify the domain. Very similar like before. I'm going to go ahead and factor the top because I can. X plus 1. Right? And on the bottom, it's already factored for us nicely. X minus 3. X plus 8. So what values are we not allowed to use? We're not allowed to use 3 and negative 8. Because if I use 3 or negative 8, those would make the denominator 0. This looks like the easiest test in the world, doesn't it? So far? Now you want to be careful here. Looking at number line, we said we're not going to be at negative 8 and at 3. So when it comes to our domain, we want to make sure we cover our domain quickly. So what x values am I allowed to use? You're allowed to use any x values except for negative 8 and 3. So we're going to go from negative infinity, going all the way to negative 8, take a break, from 8 to 3, take a break, and from 3 to infinity. And this is where kids really always get confused. They get confused about how do I write domain. The idea of domain is where am I allowed to play? I'm allowed to play in this section here, which is going to negative infinity. I'm allowed to play in the middle, which is from negative 8 to 8. I'm sorry about that. And then to the right, from positive 3 to infinity. They might have you do a union too, okay, or. All right, this next one. Let's go ahead and look at this on the actual test. This one here, we did this repeatedly, and it's about, the question is, what is the long run behavior, or another way of saying horizontal asymptote? What will this graph eventually look like at positive infinity and negative infinity? Now we have 3 rules here, and all 3 rules are demonstrated. So let's take a look at my options. There is no horizontal asymptote, a horizontal asymptote at y is equal to 0, that means we went to 0, or the asymptote is going to be 1. So in this case, the top is bigger. When the top is bigger, we say there's no horizontal asymptote. When they're exactly the same, we copy the front. The front is 1, the 1 over 1, that's going to be 1. And the third one, if the bottom is bigger, we always go to 0. No matter what, if the bottom exponent is bigger, as x gets larger, it kills the top. It's almost like the younger brother. If you have a younger brother that's taller than you, eventually you're going to lose at a fight. The problem is you just give it enough time. Give it enough time. There's an interesting weird book series I was reading. It was saying that if there was intelligent life out there in the universe, what prevents them from always trying to kill us? Okay? And the point is that if there are limited resources in the universe, eventually their population will exceed the capacity of their planet. And guess what? They're going to have to go to some other one's planet. Whose planet are they going to go to? They're going to go to ours. But what if we think, oh, they'll be peaceful? You know what? You can't always guarantee they'll be peaceful. Eventually, What if they're not peaceful and they're going to come after us? So in the book, the discussion is that if there is intelligent life out there, you always have to kill them first. Either you hide from the universe forever, or you kill them. Because if you don't kill them, maybe one day, you don't know when, but they'll come looking for your planet because they need resources, given enough time. All right, anyway, that's a weird proposition. Looking here, if you notice, I wrote no work and work. Okay, so I'll include this on your test also to make sure you know which problems you need to show work. If you don't show work, I'm just not going to give you credit. Okay, shots fired. So make sure you do pay attention here. All right, so 7 is a problem we need to show work. Why? Because I need to factor this. So let's look at the factor. Actually, you know what? For this one, what I need you guys to say is, hey, my largest exponent is right here. 3x cubed plus 5x minus 2. Rewriting it in x cubed minus 4x squared plus 2. Since they are the same exponent, same speed, we just copy the front. 3 over 1. I need to see that work. I need to see that writing. Looking at the next problem here, horizontal asymptote. I need to work on this one because you're just going to multiply the front values together. We have 2, because that's 2 over 1, times x times 3x. That's the largest exponent. On the bottom is going to be 1 times 6. Nope, I'm sorry. Times negative x times 6x. This gives me 6x on top over negative 6 on the bottom. So, I'm sorry, squared. Both these are squared. We take the front coefficients because we know it's going to be x squared in the front. Negative 1. That's my horizontal asymptote. We've done number 9 a lot before. And number 9 it says, hey, answer these questions. First, what's the y-intercept? The y-intercept at the point, well, the y-intercept is when the x is all 0. So I need to see the work. If you plug in 0, 0, 0, 0, you're seeing 20 over 3 negative. What are the x-intercepts? X-intercepts are when the top goes to 0. Now you have to show me that you can factor the top. 3 and 1, 21, 2, sorry, 10 and 2, and 4 and 5. What else? Okay, so which of these multiply to add up to 17? And we talked about factoring before. I'm going to try in my brain. 3 times 4 is 12. 1 times 5 is 5. Bam, that adds up to 17. Okay, hopefully you guys remember how to factor. If you guys need help with that, please let me know. I got some videos that you can work on. 3x on the front. We have x in the back. We said 3 times, not 5, 3 times 4 to get 12. Oh, that was a tricky one. And plus plus. That's the top. Let's look at the bottom. We have, okay, 3 and 1 and 3 and 1. Hopefully this is factorable. 3 times 3 is 9. 1 times 1 is 1. 3 minus 1 is 8. There you go. We're subtracting because it's a minus in the back. So we share 3x in the front, x in the back. And we said we're going to multiply by 3. And that has to be a 1. We need more negatives than positives. So that's going to be negative 9 plus 1 is the negative 8 we wanted. So since we factored it, now we can answer all the questions. What are the x-intercepts? X-intercepts is when the top goes to 0. So 3x minus 5 equals 0, and x plus 4 equals to 0. The x's are 5 over 3 and negative 4. Because we're making the top go to 0. What are the vertical asymptotes? Vertical asymptotes is when the bottom goes to 0, because then we would be dividing by 0. 0 over a number is 0. Easy. That's an x-intercept. But a number over 0, that's undefined. That's infinity. So when does the bottom go to 0? At negative 1 over 3 and 3. Horizontal asymptotes, lovely for us. That's x squared, so that's 3 divided by 3 is just 1. And that's how we would solve that problem. Look how much work I wrote here. Make sure you do have work for these. At least the factoring part, and you see this factoring done. Okay, f of x is a rational function given in both standard and factor forms. Thanks for doing the work for me. They're going to use the points and draw line tools to graph the following. Okay, first, draw the points where the x-intercept and y, x-axis and y, Draw points on the x-axis of the x-intercept. Sure. When does this graph go to 0? Look up here. That's the top. And top goes to 0 at 2 and -2. All right, that's what they want us to draw using this dot feature on the bottom. Next thing, graph the vertical asymptotes as lines. So I'm going to click that, and we're going to draw lines at, check it out, 3 and -3. That's my vertical asymptote. So +3 over here. I'm going to draw a line. And -3. No, sorry. Oh my gosh. Why did I write -3? I meant -1. -1. And then last one, graph a horizontal asymptote. Take a look here. This is 2x squared over x squared. So 2 over 1. We're at 2. So you have to draw these 3 lines. Do you really have to show work for this one? Not really. Can you do this on graphing calculator? It's not going to be pretty. Okay, this one was, we practiced this number 11. Number 11 is a little tough here. But let's look at some characteristics first. We want to get the vertical asymptote and the horizontal asymptote out of the way. Vertical asymptote, looking at the bottom, -x plus 1 equals to 0. So -x equals to -1, x equals to 1. Yep, 1 minus 1 is 0. And -1 plus 1 is 0. So that's my vertical asymptote. And my horizontal asymptote, we said it's going to be at, looking at the front, that's going to be 2 over -1 is -2. Okay, we got that. Now we have one more thing that we can look at. What is the root of this graph? What is the root? Look at the top. What would make that go to 0? 2 blank times 2, right? Wouldn't that cancel out with a 4? So x is 2 is my x-intercept. Okay, so you're going to be graphing x is 2. That's my x-intercept. We have a vertical asymptote at 1. And a horizontal asymptote at -2. We said -2, right? -2. And what happens is the graph will help you graph this automatically. Okay, I'm going to go ahead and show you that, demonstrate that to you guys. Remember, you guys can always come back and watch this. This will be uploaded. So we're going to click on the drawing tool. We said we're going to be at +1 and -2. That's the first thing I have to click. So we graph them both at the same time. And then I'm going to click one more point that we said. We said we had a root at +2. Okay, and that's it. Check it out. Submit question. And we got it right. Look at that check mark. Pretty pretty. Isabella, you had a question? The next question here is, pick which graph fits. Now we have some characteristics here. First, we know there's a 0 looking at the top. Looking at the top, we have a 0 at -2 and at 3. Those are the roots, okay? We have vertical asymptotes at -5 and 6, all right? We have some characteristics here. And then if I multiply this together, it'll be -x squared on top over x squared on the bottom. Our horizontal asymptote at -1. Okay, so we have a couple things we have to work with. Horizontal asymptote, look here, doesn't look like it's, oh, it looks like -1. And we have a root at +3. Nope, this is a -3. If you guys can see that, that's a -3. This is not the right graph for me. -3, +2. Okay, we have a horizontal asymptote. This looks right. But then we have a vertical asymptote at 6 and -5. We are not at 6 here and -5. That was close. Darn, that was close. Okay, 6 and -5. All right, we're doing that. We got that. Horizontal asymptote is up here though. No, we said horizontal asymptote was negative. Let's try it over here. 6, -5. We're good there. Horizontal asymptote -1. We're looking pretty good. Sitting pretty. We have roots at -2 and 3. Is that what we said before? -2 and 3. Yes, we did. -2 and 3. And if you want to verify, if I plug in zeros, what's my y-intercept? Plug in 0, 0, 0, 0. -2 times -3 over 5 times -6. This is +6 over -30. This is going to be 1 over 5, negative 1 over 5, which is a negative number, and our graph over here does show a small negative number. That's right. That's my choice. All the characteristics. Miss one, you could get it wrong. Okay, now we're going to travel to the question of holes. Are there any holes here? Remember, holes are when you divide out one of these factors. Now, does anything divide out? 10 plus x plus 10. No, x plus 10. X plus 39. No, x plus 39. Nope, there are nothing that we can divide out here. Nope, nope, nope. So we have no holes. D and E. That's what they would like you to write if there's no holes. Sorry, I kicked over my fan. Vertical asymptotes. Take a look. Vertical asymptotes are here, here, and here. 71, negative 37, and 55. Right? That's x equals 2. Okay. Alright, determine the vertical asymptotes and holes. Remove points of discontinuity of the rational function shown below. Alright, taking a look here. Oh, nice. They nicely factored it for us, right? So we have some holes. See you later, hole. We have a hole at x equals to 3. In this case, they didn't want the point. They just want the value of the where the hole is located. And then we have a vertical asymptote with what's left over. Yay. Determine the vertical asymptote. Okay, just like what we did before. Any holes, if we have any. So do we have any holes here? Take a look. X plus 7, x minus 7, x minus 3, x minus 4. There are no holes here. So D and E. But we do have vertical asymptotes at 3 and 4. Why don't we have any holes? No factors divided out. That would have been our hole. Now this problem here, you have to show work. I need to see you factor this. Two numbers that multiply to become 27, that subtract to become 6. And I'm automatically thinking 9 and 3. Isn't 9 times 3 27? 9 minus 3 6? Bam. Easy factoring problems, folks. X9, X3. And then I have to rethink, oh, I need more positives than negatives. On the bottom, 12. I'm thinking 4 times 3 is 12, right? And isn't 4 minus 3 1? Got it. X4, X3. I always write the numbers first before I write the variables. We need more positives than negatives. Unlucky for us, take a look. We do have a hole. So we have a hole at x equals to 3. And we have vertical asymptote on what's left over at negative 4. And if they want to write the x-intercept, we have it at 9, negative 9. We have a 0 if you want to plug in 0, 0, 0. We have a y-intercept at negative 27 over negative 12. We could find that out. We have a horizontal asymptote. Take a look here. Since it's x squared, just a front coefficient, horizontal asymptote at y is equal to 1 over 1, which is 1. You can find out everything in less than 1 minute. It's almost like this is a palm reader and he's reading your future. Okay. Number 17 says f has vertical asymptotes of the equation blank. Okay. And then if there are more than one value, separate them with a comma. Sure. And then graph the f has holes at some point in coordinates. Now let's take a look if we have any holes here. We've done these problems before where we say, hey, look, x squared, x plus 5, x plus 5. Hey, x plus 5. We get rid of one of them. Not two of them, just one of them. And we also have another one here, x minus 8, x minus 8. So we do have a hole. And the hole is at, in this case, I think x, they want you to write x here. Whoops, sorry. X, oh, they want the coordinate. Careful, a coordinate is a point, right? So we know it's going to happen at 8, comma, I don't know. We can figure that out in a little bit. When I divided the x plus 5 and x minus 8 out, we still have x plus 6 over 1 extra x plus 5 and an x plus 7. Now if I plug an 8 into the problem, 8 plus 6 over 8 plus 5 times 8 plus 7, this is going to be, I'm sorry, I ran out of space. 14 over 13 times 15. I don't know what 13 times 15 is. 13 times 15 is 150 plus 45. That's 195. 14 over 195. Okay, so that's our y value of our whole. And we have vertical asymptotes left over at -5 and -7. Right, that's the leftover values. Okay, let's keep on going. Find the equation of the vertical asymptotes and the equation of the slanted. Oh, slanted. Hello, slanted. How do I know if this is slanted even? Let's take a look. The top exponent is bigger by 1. So first let's come up with the vertical asymptote. That's pretty easy. It's 4x minus 3 is equal to 0. So 3 over 4, that's my vertical asymptote. They want the equation, so I'm saying x is equal to 3 over 4. The equation of slanted, we do long division. 4x minus 3, 24x squared minus 14x plus 1. Let's go ahead and divide it. 4 goes into 24 6 times, 6x. Multiply down, 24x squared minus 18x. Next step, we always do a subtraction, and remember I flip my signs on top. Please everyone take a look. I always flip my signs on top so I can see, hey, don't forget, did you remember to write that negative? And if you didn't, make sure you do it. We end up with 4x plus 1. This is going to be a plus 1 here. Multiplied by 4, 4x minus 3. Negative and plus, I'm writing so I remember to show everyone I did it. That's going to be a 4 plus 4 over 4x minus 3. Right, that's how we write it. But the slanted is only the front portions, only the line equation, because that's what the graph will look like. It'll look like 6x plus 1 eventually. What happens to the fraction? We ignore it. Why do we ignore it? Because as x gets larger, this 4 over crap, right, that becomes 0. Because as the exponent, as the variable gets bigger, the denominator shoots up to be huge, and that's it. Yeah, this week has gone by fast, I agree. Yay. Alright, this is a very similar question to the last one. Yeah. And then number 20 here, rational functions, 3 divided by x minus 2. I'm going to ask you some characteristics. What is the equation of the horizontal asymptote? Looking at the variables, there are no variables on top, so we know the bottom is bigger. And I want you guys to think, if I plug in numbers like 10, 11, 12, isn't that 3 over 8? That's a small number. 3 over 9, that's an even smaller number. 3 over 10. As x gets bigger, this gets closer to 0. Our horizontal asymptote, sorry, it should be y is equal to 0 because the bottom is bigger. A mask. Then I think that was a question. Okay, 2. Write the equation of a vertical asymptote. Sure. Looking back up here, the vertical asymptotes for the problem was looking at the bottom, making it go to 0. That's positive 2. X equals to 2. They don't want just 2. They want the equation. That means you have to write an equation. X equals to 2. That's my vertical asymptote. And then they want you to draw the vertical asymptote. Take it at 2. You can see that that fits nicely between. And folks, that's the review.